So we here are going to explore parallelograms and the special features that they have. A parallelogram is a quadrilateral, four sides, with both pairs of opposite sides parallel. These little arrows are the parallel marks. So this side is parallel to that side's parallel to that side. Now there's some special properties. Opposite sides, just to be clear on what we're talking about, don't share a vertex. This side has this vertex and that vertex. This opposite side has that vertex and that vertex. They don't share a vertex. The opposite angles, like this angle and this angle, are composed of different sides. They don't share sides. So this angle is made up of this and this side. The opposite angle is made up of that and that side. So just to be clear about what we're talking about when we say opposite sides and angles, okay? Opposite sides, opposite angles. Now, we can abbreviate a parallelogram with the little parallelogram symbol. So you can write that. And if you want to say plural, you put a little S inside. Okay, that's a notation that you should make a note of so that when you want to identify something as a parallelogram ABCD, for example, like this, okay, you will write that parallelogram symbol and then ABCD, and we know that we're specifically talking about parallelogram. Now, you can use what you know about parallel lines and transversals to prove some theorems. Here's the first one. If a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay? So if we know it's a parallelogram, then we can state as a result that that side is congruent to that side is congruent to that side. Okay, we're going to keep going and identify all of these properties and show the fact that they're true with some proofs. So here we're going to prove that. What we're going to do here is we're going to say, given that this parallelogram ABCD, that it is a parallelogram, right? We're going to prove that AB is congruent to CD and BC is congruent to DA. And how are we going to do that? Well, what we're going to do is first say that it's given that it's a parallelogram. And we know because of the definition of a parallelogram that those opposite sides are parallel. See the word parallel in there, okay? So what can we say now? Well, angles 1 and 4, if we drew this transversal line AC rather, cutting through the parallel lines, we can say angles 1 and 4 are alternate interior angles if this is the transversal. So if the lines are parallel, then alternate interior angles are congruent. So 1 is congruent to 4 and 3 is congruent to 2. Angle 3 is congruent to 2. Alternate interior angles postulate. Now, we know that AC is reflexively congruent to itself, AC, reflexive property. And so what we then have is angle, side, angle, angle, side, angle. Okay, congruence between the triangles. And if we have that, then we know that any corresponding parts of congruent triangles will be congruent. So we've proven that AB is congruent to CD, etc. Now what we want to do is we want to discuss what it means to be consecutive. Angles of a polygon that share a side are consecutive angles. So in the diagram, angle A and angle B, they share side AB, they are called consecutive angles. Okay, and there's a relationship in parallelograms that consecutive angles have. So we need to be able to identify them. Now, the theorem below uses the fact that consecutive angles of a parallelogram are same side interior angles. Like if you have angles A and B, let's say here, right? What we've got is two parallel lines, AD and BC, they're marked, cut by a transversal. This transversal is AB, and so these are same side interior angles. And what do we know about same side interior angles when the lines are parallel? They are supplementary, okay? So if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So therefore, measure of angle A plus measure of angle B equals 180. The measure of angle B plus measure of angle C equals 180 all the way around. C and D sum to 180, D and A sum to 180. Yep. So then, in this illustration here, which is kind of small, but I'll zoom in on it big for just a second. And let me bring it to the front. Okay, what we've got here is this parallelogram, and we know that this angle is 64 degrees, okay? So what they're asking is, what is the measure of angle P up here, okay? Let me shrink it back down. Now, what do we know? We know that angle P and angle S, which we know is 64 degrees, are consecutive angles, and we know that they are supplementary. So, and here's the write-up of the whole thing, is that the measure of angle P plus the measure of angle S needs to sum to 180, and we know that the measure of angle S is 64. Through substitution, we plug it in there, and we then subtract 64 from both sides, and we find that the measure of angle P is 116. Correct answer is C. Now, this is just pointing out, if you want to get started from the diagram, you know what the measure of angle PSR is. PSR, it's 64. And you know that angle P and angle PSR are consecutive angles, so you can write that out like that. Now, suppose you have this got it problem here. You adjust the lamp so that the measure of angle S is 86 degrees. What is the measure of angle R in parallelogram PQRS? You'll find this probably pretty easy, but take a shot before you restart it and check your answer. Okay, so you see that the answer is 94, because 94 plus 86 sums to the 180 that you need. Now, another theorem here is that if a quadrilateral is a parallelogram, then its opposite angles are congruent as well. Okay, and what we'll see is that if these need to sum to 180, we're going to do a proof on it, but the idea of it is if angle B and angle A sum to 180, and angle B and angle C both also sum to 180, then in order for angles A and C to both get B raised up to 180 together, they have to be the same. That's the idea. We'll take a look at the proof here. Okay, so first of all, the note here says, why use a flow proof here? And it just allows you to see the pairing of the statements. So watch what the statement is. We know, given that it is a parallelogram, ABCD is a parallelogram, okay? So what do we know from that fact? We know that angle A and angle B are consecutive angles, angle A and angle B. We know that angles B and C are consecutive angles, and we know that angles C and D are consecutive angles, okay? Now from there, we know that they are supplementary because consecutive angles are supplementary. Each one of those pairs is supplementary. So what we know then is that angle A is congruent to angle C because supplements of the same angle are congruent, and same thing here. Angle B is congruent to angle D because supplements of the same angle are congruent. So we've proven here that angle A is congruent to angle C, opposite angles, and angle B is congruent to angle D. All right, so you can write a proof on this one. You're going to use this diagram at the right. We know that that this ABCD is a parallelogram. It's given. And we also know that side AK is congruent to side MK. And if we know that AK is congruent to MK, think about what that means for a triangle AKM, okay? What you're going to eventually do is prove that angle BCD, this angle right here, is congruent to angle CMD right here. Give it a go, and we'll come back and check the answers. This is a neat property of parallelograms, that the diagonals have a special property. If we know that the quadrilateral is a parallelogram, notice we're starting a lot of theorems here saying if a quadrilateral is a parallelogram, right? It's this if-then conditional statement. If it is, then we know that the diagonals bisect each other. When they bisect each other, doesn't mean that they're the same length, but it means that the two sides that are the two smaller segments that are formed by where the intersection is will be congruent, okay? So if that's E in the middle, then BE is congruent to DE, and AE is congruent to CE. Yep, and so we can use that theorem to find unknown lengths. Let's do that. Okay, so what we're going to have to do is write a system of linear equations and solve the system of equations. You did this last year in Unit 6. We're actually doing this in algebra currently. Okay, so solve a system of linear equations to find the values of x and y, and then find the lengths of km and ln. Okay, give that a go, set them up, and see if you can solve this. You'll have to remember how to solve systems of equations. Okay, so what do we know? We know that the diagonals bisect each other, so therefore we have Kp equal to Mp right there. So you write that out as y plus 10 equals 2x minus 8. We also know that Lp and Np are congruent, so x equals y plus 2. You know what x equals in terms of y, so you can take this other equation, and wherever you see x, you can substitute in its matching algebraic expression. So y plus 10 equals 2 times y plus 2 minus 8. Okay, now we have an equation in one variable, and we can solve for the variable. And when we solve this all out, we get y is equal to 14. Now we know what y is. We still have to find out what x is, because up here, this was not the actual measure of x. It was just what it was in terms of y. So we can take one of the equations, x equals y plus 2, replace y with what y's value is, and we find that x is equal to 16. So y is 14, x is 16, and now you can plug into the expressions. If we know that km is just congruent to 2 times what kp is, because that's bisected, so that equals that, then you can say 2 times y plus 10, and we know that y is 14 equals 2 times 24, or 48. And for ln is just 2 times this length, and lp, and so we say 2 times lp, and lp is equal to x, and we know what x is at 16. So 2 times 16 is 32, and we have those lengths. Yep. You'll try this now. They tell you that this is a parallelogram that's given. What are the lengths PQ and, PR and SQ? So you'll set it up like the last problem and solve it. And then the reasoning problem just says, does it matter which variable you solve for first? And explain. So write your answer out and then check it after the break. Okay, one final theorem here, and this one's pretty cool. You can see 3 or more parallel lines. If you cut them by a transversal and you get equal measure segments here and here, okay, if line AB is parallel to line CD, which is parallel to line EF, and you know that AC here is congruent to CE, then that means that this is going to be equal portion here, and any other transversal is also going to have the same feature. So then BD will be congruent to DF. 3 or more parallel lines cut off congruent segments here and here of one transversal, then they cut off congruent segments on every transversal. Neat. Let's apply that to a problem. Okay, so in the figure at the right, AE, this line is parallel to BF, is parallel to CG, is parallel to DH, and we know that AB is equal to BC is equal to CD, which is, each one is 2, okay? We also know that this EF is 2.25, so what is the length of EH, okay? What do we need to know? We know the length of EF. To find EH, you need to find the lengths of FG and GH so that we can sum them together. Try that, and well, actually, this is our problem to do together, so sorry, I'll show you that. Okay, we know that they're all of equal length, and we know that EF is equal to those 3 lengths together. So since they're of equal length, we can substitute each length with the measure that they are, and so EH is going to be the sum of them, or 6.75. Okay, you're going to do the same thing here. You're going to use the same figure at the right. What if EF and FG and GH were equal to 6? And we knew that A, D, this whole span of those three segments together, was equal to 15, what would this one segment be? Solve that and then check your answer. Okay, give these lesson check problems a go and see how well you understand this. Yep, good luck.